PyTest is one of the most widely used test frameworks in the software world. It started as a tool for unit testing, but it has moved far beyond that. Today, PyTest is also used to drive complex system tests on real hardware with real-world interfaces. In this video, we will look at what PyTest is, how it is used for system tests, and what advantages and challenges come with it. PyTest is a framework for software testing based on Python, hence the name. Python itself is the most popular programming language today, and it has become more and more common across the entire software industry. PyTest is essentially an extension of Python that adds the structure and the tooling needed to write, organize, and to execute tests. Because it is built on Python, you can also get the full Python ecosystem behind it. The most common use of PyTest is unit testing. You can call it pure software testing, if you will. A unit test verifies a single function or method in isolation, and PyTest fits this purpose very well. PyTest automatically discovers files named test_something.py, and inside those files, it picks up any function that starts with test_. And those tests are plain Python functions, and that keeps the entry barrier very low. On top of that, there is a large ecosystem of plugins for coverage, evaluations, mockings, etc. So for unit testing, PyTest is a strong default choice. For system testing, it is a bit different. Here, PyTest is no longer just verifying a small piece of code, but it becomes part of the testing infrastructure and can act more like a test orchestrator. It drives the full integrated system and not just a single function. To do that, PyTest is combined with Python libraries that can talk to real hardware and real interfaces. You have, for example, PySerial for UART, PyCan for CAN buses, or any other proprietary interfaces and self-developed solutions. This means PyTest can be integrated with hardware-in-the-loop test benches, with simulators like Canary, DSpace, or other tooling. There are also plugins that bring requirements language closer to the test code. The plugin PyTest BDD lets you write tests in a behavior-driven development style using Gherkin syntax with given, when, and then structure. This makes the tests readable for people who are not pure programmers, and it brings them closer to the use case description. Using PyTest in system testing has several clear advantages. The first one is cost. PyTest is free and open source, with no license fee, unlike commercial tools such as ECU test. The second advantage is the ecosystem itself. Through Python, you can access to almost any protocol, instrument, or API you might need. And the third advantage is skills. Many test engineers already know Python, and the tests themselves often read like specifications. And last but not least, the technical advantage. PyTest is flexible, it scales from a few tests to very large test suites, and the framework itself is stable and well maintained. But of course, there are also disadvantages. PyTest was not purpose-built for hardware or system tests. It does not come with native requirements management, no traceability matrix, and no test plan tooling. There's also no out-of-the-box integration with tools like Doors or other requirements management tools. There's also no visual test composer or sequencer, because everything is code and which can shut out test engineers that are not programmers. So everything is code, which can be an issue for test engineers that are not so technically involved. So they need probably a layer on top of PyTest to work with it. Reporting is another weak point. The default reports are functional but not stakeholder friendly. So you also need additional reporting tooling there. And finally, you have to deal with the flakiness from timing, networking, and hardware behavior. Complex systems may react as complex and make therefore testing difficult. So to tackle all of these, there are some practical challenges you have to face. First one is the integration of the embedded system itself. You need to make the data inside of the system accessible in a form that can actually be used by your test cases. The second challenge is the setup of the proper test management system around PyTest. So PyTest only gives you the execution layer, but you still need a place where test plans, test runs, etc. are managed and controlled. And the same is for requirements. Third challenge is the traceability. Requirement-based tests and use case-based tests have to be linked back to their source, and that link has to survive across all versions and the test cases. PyTest does not solve this for you, but you have to build it around the framework. So PyTest is very good for unit testing, and it can be used as a framework in system test as well. But you have to set up and connect all the tools around it for requirements management, traceability, reporting, and test case handling. Then PyTest can serve as a very good orchestrator for your system test.